Object recognition is one fundamental task in computer vision. It allows machines to identify and classify objects within images. However, for the Microsoft team, more than just categorizing things in single object or iconic pictures needed to exist. They aspired to create a dataset that could push the boundaries of artificial intelligence, providing more contextual information. I mean, in the end, we want to be able to use our models in the real world, right? This idea led them to ponder a more profound question. How can a dataset help to improve scene understanding? But how can this ambitious goal be achieved? We are the team of fantastic datasets and where to find them, and this video is the MS-COCO dataset explained. It is 2014, 1 year before TensorFlow was released and just before the foundation of OpenAI, 5 years after the release of the famous ImageNet. This year, Microsoft published a large-scale dataset ready to compete against other big famous databases like the previously mentioned ImageNet, Pascal Visual Object Classes, and SUN. Microsoft's publication was COCO, which is an acronym for Common Objects in Context. It contains classes divided into two main categories: 91 objects like person, truck, wine glass, or cell phone, and scenes that include playground, gas station, dining room, and office. It addresses three key points. First, detect non-iconic views of objects. Second, contextual reasoning between those objects. And third, precise to delocalization of objects. It has 2.5 million labeled instances in roughly 330,000 images. So you could ask yourself, how did they gather this amount of pictures? And how did they manage to label that much information? As always, you have to prepare the right tools to do it, as well as tons and tons of, that's right, patience. Well, let's start with the first question. What was the tool Microsoft used to find the files? Flickr. But what is distinctive about this application? There, one can usually find less iconic pictures from amateur photographers. Besides, it provides the metadata of the files. So, if you are looking for a source of non-iconic images for your project, it is worth checking it out. But hey, after gathering the initial images, you usually have to perform a filtering task to avoid having invalid samples. That is actually what the COCO team had to do in the first instance. Here is an example of what they did. They asked their workers to select images that were desirable for their purpose. For example, click on images where you see both a person and a bike. It is worth mentioning that the filtering also had to exclude cartoons or paintings. It makes sense, right? However, one can't easily find some specific categories co-occurring. For example, a bear and a bicycle. Well, maybe a motorcycle. Anyways, in that case, they filter by multiple objects and bear. But what about this kind of image? If they were looking for a bear, they might not be that accurate if they include it, even though it is a bear, a teddy bear. For that purpose, they had a separate class for it. The previous refinement assignment was complete. It was time to annotate it. So let's answer our second point. The team had an army of workers, a filtered dataset, the tools, and the plan. The annotation pipeline consisted of three tasks: category labeling, instance spotting, and instance segmentation. In the first task, the workers had to drag and drop icons to match the objects in the image with the 91 categories belonging to 11 supercategories. Then they mark each instance or occurrence of an object. And finally, trace the contours of individual objects. But what about having tons of occurrences in the same picture? They mark them as a crowd. After some internal evaluation and examination, they finally had a dataset ready to compete with the by the time current famous databases. So, what was new in this dataset? Well, they presented more categories and instances per image on average than ImageNet and Pascal VOC. Let's take a look at this graphic. This figure shows that COCO presented fewer categories than ImageNet, Caltech 256, and SUN. Still, it had more instances per category than all of them. Nevertheless, the SUN database displays more contextual information because its target is to categorize the same types and identify the objects found within. So, after over 30,000 working hours in their first publication, with an additional 40,000 hours in the last edition in 2015, they had the stats. Thus, it was time to test their dataset. They used a discriminatively trained part-based model and trained it on COCO and Pascal VOC, finding a drop in performance using the first mentioned dataset. But why? They related this drop to a higher difficulty of detection in non-iconic images, together with an average smaller size of objects than in Pascal. That observation derived in a second finding alongside a higher complexity of COCO. Training a model on it could lead to a better generalization than training on not so difficult datasets. So, as we can see, they created a formidable dataset ready to test algorithms in AI vision tasks. Let's not get stuck in specific details and jump into the applications for this dataset. As we saw, the dataset was ready and the people was ready as well to start using it. The time for the challenge eventually had to come. They started the tasks that took place yearly from 2015 to 2020. But what can we do with this dataset, and what were those challenges about? In 2015 came the first caption and object detection tasks. In addition, the following years gave rise to more challenges like key point detection, stuff, and panoptic segmentation, as well as dense estimation of human pose in 2020. That's actually how enthusiasts, students, researchers, and data scientists in general started to test their models on COCO. That led to a flourishing of innovation and healthy competition within the AI community. In this way, there have been promising results in computer vision, using it to benchmark algorithms and frameworks like the detection transformer, region-based fully convolutional networks, and the well-known You Only Look Once in its different versions. Speaking of YOLO, it is worth mentioning that one of its latest developments, You Only Learn One Representation, YOLO, combines explicit understanding with the implicit knowledge learned from COCO during the inference phase of making a prediction. However, the best results for object detection by the beginning of 2024 are obtained by CodeEater, with an average precision of 66% on the 2017 version of COCO. In the case of instance segmentation, EVA, Explore the Limits of Visual Representation at Scale, has the record with an AP at mask of 55.5. If you want to check it in more detail, I left links to the papers in the description. So, whether you like to dive into instance or object segmentation, I would recommend you to take a look into these models. Or why not? Develop your own models and test them on COCO, opening your door to innovation, improving your skills in this ever-evolving field, and maybe creating something new. Either way, you have the opportunity to gather some knowledge on the way, and in the end, that's what matters, right? In contrast to the advantages and applications of COCO, we should also look at the limitation of this dataset. What about benchmarking a benchmark? That is actually the name of a paper released in 2023 that questions the reliability of MS-COCO. The Team Sama released a re-annotated version highlighting that there is no perfect dataset, and, in consequence, that it's meaningful to know the nuances and biases present in a dataset, as they stated. Here is an example of what they did. They distinguished the individual instances in crowd images and annotated each object with more precision. Now, let's jump into more comments about COCO. In mid-2022, Jamie Murdoch, founder of an AI startup, published an article on Medium.com titled How I Found Nearly 300,000 Errors in MS-COCO. He explains how, with one of his tools, he can find different types of errors with the background, overlapping objects, and localization. So, if you want to check this article, follow the link in the description. In conclusion, when you make your dataset or use one state-of-the-art database for your projects, you should check it to obtain more fine-grained results. Of course, it always depends on the scope of your project, the time available, and whether you can live with more or less coarse results. To summarize, we saw how Microsoft's COCO publication has made a meaningful contribution to artificial intelligence. They invested tons of time creating a dataset loaded with images and annotations. COCO has facilitated research in a wide range of computer vision tasks, including object detection, segmentation, and captioning, becoming a benchmark dataset that is still widely used in the research community, having in early 2023 over 42,000 citations on Google Scholar. We also saw some flaws this dataset might have, but hey, nobody's perfect. With COCO, Microsoft has demonstrated its commitment to advancing this field by promoting innovative open research, playing a significant role in developing new methods and paving the way for future research. And even though it's been almost a decade since the release of this dataset, COCO continues to be a topic of significant interest and discussion. Thanks for watching this video. If you like it, please make sure to click the like button and subscribe. If you want to go deeper into this world of fantastic datasets, you know where to find them, or at least where to find more information. So check out further videos on our channel. Until the next time.